Hi, my name's Andrew Hall, and I'm a program manager on the Visual Studio Diagnostics team. One of the problems that can affect .NET memory applications running in production is problems with memory consumption. In this video, I'm going to show you the new .NET memory analysis feature that we added to the Visual Studio 2013 Ultimate Edition to help solve these problems from dump files. We're going to cover features such as seeing object size, counts, and references that are keeping the objects from being garbage collected, as well as the more advanced features such as the ability to compare files in inclusive sizes. The scenario is my productions team has noticed that one of the applications is frequently increasing in memory and having problems in the production environment, so they collected 2 dump files with the full heap. I'm going to start by opening the newer of the 2 files, so I can see that this one was collected more recently and is bigger. And so when I open it, I'm presented with the dump summary page in Visual Studio. I can see the name of the process. It was W3 wp.exe, it was an x64 process, and the heap information is present. Since the heap information is present, I now have an option to debug the managed memory of this application. I'm going to begin by clicking the Debug Managed Memory, and it's going to go ahead and analyze my heap and then bring up a summary report of the memory data in the process for the .NET memory. So I can see that I have a table here that shows me object types. It shows me the count of those objects, how many of those were present in memory when the dump file was collected, the size of those, how much memory they are taking up, and then the inclusive size. Inclusive size is how much memory they are preventing from being garbage collected. Because .NET is a garbage collected runtime, any memory that you're referencing is not being collected. The way to have it be garbage collected is to free all of the references. I can also see that I don't have many types in this table, and this info icon up here tells me that view settings have filtered some object types, and the view settings that are filtering those are just my code and collapse small objects. So if I go ahead and turn those off, I can see what it does, and it increases the number of objects that I have. In general, I want these on because these help remove noise and help me find my issue more quickly. So I'm going to go ahead and turn those back on and focus on the things that I really care about. I can see here that I have a user, there's only one of them, but it has an inclusive size of about 29.5 megabytes. I can also see that I have 29 user objects in memory, and those also have an inclusive size of about 29.5 megabytes. If I click on the list that is holding users, I can see the paths to root. These are the paths that are preventing it from being garbage collected going back to the GC roots. If I click on the References tab, I can see what objects that this is referencing. So I can see that the list of users is referencing an array of users, and then if I expand the array of users, I can see that that is referencing 29 users, and then when I expand that, I can see that those 29 users are referencing 29 byte arrays and 58 strings. One of the other features that .NET Memory Analysis supports is the ability to compare so I can see what's changed over time. I'm going to go to the Compare To up here and select a baseline. I'm going to browse and I'm going to choose the first dump file that the productions team collected. When I open this, it's going to analyze the second dump, and when that completes, it's going to show me the differences between the two. So in this case, I can see that I have count, and it's added a count diff, so I can see the number of objects that have increased in memory. I can see a size diff, that size change over the same period of time, and then the inclusive size diff. In this case, I can see that users are increasing, and so those are likely the cause of my leak. If I look at user, and I look at the paths to reference, I can see that it's being held alive by a list, which we looked at earlier, and I can see that that list is actually represented by a static variable that is m_user_cache. So if I want to search in my application, I'm able to see or find the variable that is holding that alive, and so I can quickly figure out how to release that reference so my memory gets collected. Additionally, the tool offers the ability to see individual instances, so I can look at the largest instances in memory, and I have the ability to see the same information, the paths to root for that individual instance, and then the references just for that individual instances, as opposed to the summary information when I select the summary row. In this video, we cover the new .NET Memory Analysis feature added to Visual Studio 2013 Ultimate. We went over how it helps you to solve memory problems in production by analyzing memory data from dump files.